Now I want to show you the Smart Data Analyzer by Esri Deutschland GmbH. The Smart Data Analyzer is the integration of InfoZoom technology developed by the Fraunhofer Institute into the Geographical Information System ArcGIS for desktop. This plugin is an alternative to the complex, time-consuming selection mechanism Select by Attributes. It will save you up to 99% of time compared to the previous data selection mechanism. Since data become transparent immediately, inaccurate data can be detected and corrected before the selection. This yields valid results. The Smart Data Analyzer is easy to use and features intuitive navigation. It only takes a few minutes to introduce beginners to the tool. Moreover, it is faster and more versatile than SQL, MS Access, Excel and other selection mechanisms. The bidirectional data exchange between the map and the Smart Data Analyzer offers completely new analysis options and allows connections to be identified within seconds. External data can be effortlessly imported into the ArcGIS desktop. External tools to edit or prepare the data beforehand are no longer required. This can all be done in the Smart Data Analyzer. First, I want to show you how InfoZoom or text files that contain geographical data, in our example coordinates, can be imported into ArcGIS. Second, I will explain you how data are displayed in the Smart Data Analyzer. Next, I will show you how you can use your Smart Data Analyzer to filter data, carry out plausibility checks and correct data, automate steps, and analyze data. This is the ArcMap by Esri. A base map of Chicago has been integrated. Maps of other locations worldwide and more map types are available online. At the center of the screen, you can see the main map window. To the left, the table of contents is shown, in which all data are listed that are included in the GIS project. There are several toolbars at the top. You will also find the toolbar of the Smart Data Analyzer here. It can be used to import text files, for example. I want to import crime data on Chicago now. To do so, I open the context menu of the Smart Data Analyzer and click Open File to load the table. I change the file type of the text file to CSV, select the Crime Data Chicago file and click Open. Now the import wizard is displayed. I can define various file-specific settings here, such as the coding, separator, and the position of field names and data. In the preview, I can check whether the structure is recognized correctly. On the right side of the ArcMap, I can see the table of the Smart Data Analyzer. It contains 256,648 records, with one record representing a case. To link the table with the map via the coordinate fields, latitude and longitude in this case, I select the Create a Temporary Feature Layer function. The progress of the import is shown, and a few seconds later all crime data are displayed as dots on the map of Chicago, which gives us a geographical view of the data. The tabular data have been converted into geodata, so-called point feature layers, and are ready to be further analyzed. To show you how data are displayed in the Smart Data Analyzer, I will open the text file in Excel first. You can see that the file is structured like a normal table. The first line contains the column headings. They will be imported as attributes later. Below, each record is displayed in a line so that we have to scroll through all the data if we want to find an answer to a specific question. The Smart Data Analyzer rotates these data by 90 degrees to display them. As a result, the attributes are shown on the left. One column represents one record. In the wide table view, I can identify the structure of the table. I have entered latitude and longitude as values. The arrest attribute has the values true and false. There are other attributes such as case number, date, primary type, description, and local description. I can display these data on a single screen. To do so, I click Overview, which triggers an animation. All values are sorted independently of each other now, and identical values are combined in cells. In the Arrest attribute, there are significantly fewer true values. They only make up about 30% of the records. This means that persons have been arrested in about 30% of the 256,000 cases. These data are from 2011. If there are many different values, I can use the value list. It tells me that the data contain 32 primary types. I can sort these alphabetically in ascending or descending order. I can also click the column N on the right to sort them by frequency. I need only one click to find out that most records are thefts and that there are only 2 other offenses and 2 other narcotic violations. I can answer any question on my data fast by making selections in the Smart Data Analyzer. The data on the ARC map can be dynamically adjusted to my selection. I enable dynamic synchronization in the toolbar of the Smart Data Analyzer for this purpose. First, I want to see all thefts committed on streets which involved arrests and whose amount of damage exceeds $500. I only need 4 clicks to select 49 cases out of 256,000 cases. The view is adjusted to my selection immediately. Relevant data are highlighted in light colors, which gives me a geographical view of the areas that are affected most. By clicking Reset, I reset my selection to answer the next question. I can also select the data directly in the Smart Data Analyzer. For example, if I only want to have a look at an area in West Chicago, I can select the data on the map by pressing and holding the mouse button. I can now see that most crimes in West Chicago were committed at the airport and that their primary type was mostly theft or other offense. If I want to check all cases in West Chicago which involved arrests, I can see that criminal trespass and narcotics were committed most often. If I want to see all cases of prostitution without arrests, I can just zoom into the values. I can immediately identify the hotspots where these 54 crimes were committed. In the background, I can enable the Chicago income layer to see the income structure of these areas. I can select the data on the ARC map or in the Smart Data Analyzer. To do so, I click the Selection menu item, then Interactive Selection method, and then Select from Current Selection. To select the data on West Chicago only, I mark the relevant area using the lasso tool. The 28 records that meet the desired criteria are automatically displayed. It would be difficult to select these records in the table because I had to check which blocks belong to West Chicago. If I want to forward the data as a text file to a colleague responsible for this area, I can export my selection to a CSV file, for example. The 28 selected records are saved as relevant_cases_Chicago.csv. You can use the Smart Data Analyzer to carry out plausibility checks of your data and correct them immediately to achieve accurate results. Values are not only displayed in the overview, but also on the value list, which is very useful to handle many different values. If I open the value list of primary type, all values are sorted in ascending order. Irregularities can be found at the top or bottom of the list. This allows me to identify incorrect spellings of criminal damage immediately and correct them fast. To do so, I have to show the Edit bar in the Smart Data Analyzer. I then select the incorrect values and enter the correct value in this bar. Now I want to show you how you can record frequently performed steps as a macro. They can also be forwarded to other users to work with the same data structures. As a first step, I show the query bar and click Reset. If I want to create a macro that always selects thefts with an amount of damage of over $500, I perform the corresponding zoom steps one after another and then click Define in the query functions. I enter the name of the query, thefts over $500, and save it. The query is now displayed in the selection window where several macros can be stored. When I click Perform, all selections saved in the query are automatically made so that I can see the relevant results in the analyzer and on the map. To forward these data to other users, queries can be imported and exported as files. The Smart Data Analyzer offers a variety of analysis options. Here are some examples: analysis with date values, aggregations. First, I want to show you how you can split date values. To do so, I click a date value such as date in our example. I can now create a date group which splits this attribute into more attributes. Further filter options such as year, quarter, month, calendar week, and day are made available with a single click. If I split a date value with time, it would yield the attributes hour, minute, and second. This allows me to carry out more detailed analysis. For example, I can define that I want to see all crimes in 2011 that were committed in the first quarter on Friday. Of these crimes, I want to highlight all cases where heroin was involved. The Smart Data Analyzer displays the areas that are mainly concerned. Now I want to show you how you can create KPIs. I want to find out in which blocks most thefts are committed. To do so, I create a new attribute that determines the number of cases per block. First, I zoom into the thefts. And then, in the value list of the new attribute, I zoom into the blocks with the 3 highest values. The ArcMap shows me where these blocks are located.